So looking at part C then of the 2020 mock question that you had to do the other day, right? So it's causing, part C's are causing a bit of an issue for 5 or 6 of you, alright? So just to go through in a little bit more detail, alright? So when you have your table done, your total resistance, alright? So your total resistance on this question was 0.5282, alright? Then you would go to your formula, so 1 over the total resistance gives you your U value, alright? So you have to work, that's the way you would normally work, okay? So that's what we're going to do here. So we're going to say 1 over total R equals our U value, so then 1 over 0.5282 gives us 0.5282 gives us our U value of 1.8932 watts per meter squared K. Alright, so that's the first step, right? So you'd find the U value, most of you able to do that. So I'm just going through this to show you how we're going to have to work a little bit in reverse. Alright, so we're going to have to look at the existing wall. So existing wall and then new wall. Right, so the existing wall, we're trying to get our resistance values back. Alright, so that's what we're looking for. So the existing wall U value is 1.8932. New wall, the resistance that we're looking to get, or sorry, the U value we're looking to get in the new wall. So the U value of that, 0.15, big difference. Alright, and then we're trying to find the resistance of both. Okay, so we're trying to get back up into this column that would be on your table up above that. Okay, so looking at this here, if we're trying to find the resistance value, working in reverse. So look at what we have. We have the U value and we have number 1. So if I'm trying to find total resistance, put my finger over that, I have to divide 1 by the U value, and that's going to get me my resistance figure. Okay, so 1 divided by the U value. So here 1 divided by 1.8932 equals whatever, and then 1 over 0.15 equals whatever. We'll do that calculation now. So this one here, 1 divided by 1.89, should be working in reverse, should get you 0.5282. Down here, slightly trickier, so it's 1. So I'll show you what I'm putting in. So 1 divided by 0.15. 6.6666, so 6.6666. Now, we're trying to find what the resistance total would be now for this new insulation. So that's the resistance total we're required to have. That's what we have so far, right? So that's what we have so far on our wall. We're trying to get it up to that value, right? So we need to find the difference. So if we have 6.6666 minus 0.5282, that'll give us the value of the resistance that we need to find. Alright, so we have 6.66 in that minus 0.5282, 6.1384. So 6.1384. Alright, so that's the resistance of the insulation that we're required. Alright, so then that's our value for R if we were working in our table, and then we have the value for conductivity. So conductivity, right, it was given to us in the question. Okay, so it was 0.037 watts per meter squared. So now we have two values. So when we were doing our formulas before, alright, so one of the formulas to find resistance, you divide thickness by conductivity, right? So this is our triangle for this. Okay, so resistance and conductivity, right? So T for thickness, R for resistivity, and K for conductivity, right? So that would be our triangle for that. So now what do we have? So we have our resistance and then we have our conductivity. Alright, so to find our answer in this case here, if we work with our figures. So we're trying to find thickness. So we're going to multiply 0.037 multiplied by 6.1384. Okay, so there in the calculator, multiplied by 0.037. Alright, and that gets me a value of 0.227. Alright, so, and that's meters. So when we are starting off doing our U-value question in our table, what we usually do is we convert our millimeters to meters, alright, for the purpose of the calculation, right, because it's meter squared. Okay, so now that's 0.227 meters. So then if I want to put that into millimeters, which I do, I'm going to multiply that by 1,000. So multiplied by 1,000, and that gets me 227 millimeters, and that's the measurement for the insulation required. Alright, so hopefully that was where you would finish off at the bottom of your table. You do your calculation as normal to get your U value. Alright, so the only reason I've done that is to show you how I'm working slightly in reverse down here. Okay, so I'm trying to cover up what I'm trying to find. So I was trying to find the total resistance. So I'm trying to find, that's the resistance that should be at the bottom of the table if I had the insulation included in that list. Alright, so then that's what I have originally, and I'm trying to find the difference. So that's why I take one from the other. So take away that one from that guy. That's the resistance that would be in the total column on the right hand side of your table if the insulation had been included in the original calculation. So that would be that total. So then you would, that was the conductivity value for it then, which allows us then to find our thickness. Alright, so working off this here, if that helps you, so you multiply 0.037 by 6.1384, that gets your answer in meters. Multiply by 1,000 gets you your thickness, alright, in millimeters. If you have other questions completed, maybe just write down your total resistance and then your part C of it, and try and work from there and see what answer you come up with, and send them on to me as well if you're having issues with that, please.